Okay, so now that we have a better understanding of what limits are, we'll go into the definition of continuity. So the three conditions of continuity are, first of all, so for a function to be continuous, for a function f of x to be continuous at a point x equals a, f of x must meet the following three conditions. Okay, so first of all, the limit of f of x as x approaches a has to exist. Meaning, of course, that the left-hand limit as x approaches a of f of x and the limit of f of x as x approaches a from the right side have to be equal to each other. Okay. The second condition is that if I plug in x equals a into my function, there will be a value, f of a. The third condition is that the limit as x approaches a of f of x has to equal f of a. So if a function meets all three conditions, then it is continuous. Let's do a quick example, just looking at a graph. Okay, so if I look at a graph of a function, let's say 2, 3, 4, 5, 2, 3, 4, negative 5, 1, 2, 3, 1, 2, negative 3. Here's x, here's y. Okay, so let's say my function f of x looks like this. Okay, so let's look at the different discontinuities of this graph. So let's look at, is f of x continuous at x equals negative 5, negative 2, 0, 1, 2, and 5. If not, which conditions are failed? Okay, so we're going to answer the following question. First, is it continuous? Is the function continuous at these x values? And if they aren't continuous, then which conditions are failed? So remember, our three conditions are the limit of f of x as x approaches a exists, f of a exists, and then the limit of f of x as x approaches a is equal to f of a. Okay, so let's look at each x value here. So at x equals -5, okay, it looks like as I approach x from the left side, as I approach -5 from the left side, and as I approach -5 from the right side, I have a limit here at 0. And at 5, my value is 0. So x equals -5. It looks like my limit as x approaches -5 exists. And f of -5 also exists. And they're both equal to 0. So yes, I am continuous at x equals -5. Let's check if I'm continuous at x equals -2. So let's see, as I approach -2 from the left side, looks like I'm getting closer and closer to 2. And as I approach -2 from the right side, I am still getting closer and closer to 2. So yes, the limit as x approaches -2 does exist. Okay, and it is equal to 2. Let's see if f of -2 exists. So at -2, I have a value at 1. So yes, f of -2 exists, and it's equal to 1. So the first two conditions are met. However, as you can see, the limit as x approaches -2 of f of x does not equal f of -2. The limit is 2, the value there is 1. Therefore, this function is not continuous at x equals -2. Okay, so we can keep going. Oh, and the third condition is the one that's failed. Okay, so you can keep going on your own. Pause the video if you like and see where this function is continuous at, and if it is not continuous, which conditions are failed. I'll let you practice with that. Let's go on to one of the essential questions that we covered in class, which is the intermediate value theorem. So remember, there was this question that if you're going in your car traveling at 65 miles per hour and you suddenly brake to 0 miles per hour, the question was, did the car travel at every intermediate speed between 65 miles per hour and 0 miles per hour? And we know that the answer is yes. That's what we learned in class. So just going to draw a doodle of a speedometer. So let's say your speedometer is here. Starts at 0. Oh, sorry. If your speedometer is here at 0, okay, and here's all the numbers in between 0. Let's say here's 50 miles per hour. And then let's say here's 100 miles per hour. If you're over here at 65 miles per hour, okay, when you drop down to 0, you have to hit every possible speed in between 65 miles per hour and 0 miles per hour. So we know that this is true. And therefore, since for every time period, you have the speed in between 65 miles and 0 miles per hour, this is a continuous function. This concept essentially is what the intermediate value theorem is. Okay, so the intermediate value theorem says, okay, that you have some function f of x that is continuous on some interval a through b, then for every number m between f of a and f of b, there exists a number c that's in between a and b such that f of c is equal to m. So this is a lot of words. So what does this really even mean? So let's do a quick graph to show what this means. Okay, so for example, let's say you have some continuous function. Here it is, between a and b. Okay. At a, you can see there's a value f of a. At b, you can see there's a value f of b. That's the value at x equals b. If I choose any y value between f of a and f of b, let's say m, right here, the intermediate value theorem says that there should be some c in between a and b such that f of c is equal to m. So if I plug in c into my function, I will spit out the value m. Okay? So this is what the intermediate value theorem is saying. An example problem that might deal with this is often when proving that roots exist. So we can talk about that in the next lecture video. But for now, make sure you understand what the intermediate value theorem is saying. That if I have some continuous function on a closed interval a to b, if I choose a value m in between f of a and f of b, then there is some x value c that when I plug it into my function, I get that m. Okay. So in the next video, we'll talk some more about the intermediate value theorem as well as how to evaluate limits.